Europe doesn't have a technology problem. It has a coordination problem.
If you focus on electricity separately from heating and separately from cooling, you have different islands that don't communicate with one another.
What matters to tenants as well is that it's the possibility of having a free mind and being sure that the system works in itself. Heating and cooling are where the energy transition becomes real. They affect bills, comfort, and the resilience of buildings and neighborhoods. After chairing an event on heat pump in Brussels at the end of 2025, one thing was clear to me. Europe doesn't have a technology problem. It has a coordination problem. We keep deploying heat pumps without aligning buildings, energy systems, financing, and the people expected to use them. That's why I wanted to have this conversation. I'm joined by Vladimir Gjorgievski, who works on electrification, sector coupling, and integrated energy planning in contexts like North Macedonia, where limited gas infrastructure and growing cooling needs force system-level choices. And by Louise, Meister, who works at the Austrian Energy Agency on heat pump rollout, energy communities, and buildings. Through the EU-funded Install Res project, she looks at how business models, coordination, and communication shape whether clean heating actually works in multi-apartment buildings and social housing. Today, we talk about heat pumps as parts of buildings, communities, and energy systems, and about what it takes to scale clean heating without shifting cost and risk onto residents. Louise and Vladimir, welcome to the show. I would like to begin with your own trajectories, because the way you both approach heat pumps is clearly shaped by where you work and what you have been seeing on the ground. So Vladimir, if I can start with you, you've been working on electrification, sector coupling, and integrated energy planning, but in a context where the energy system doesn't really follow the standard European models, right, in North Macedonia. So what pulled you towards heating and cooling specifically, and why did it become such a central part of your work?
Yeah, thank you. So to answer that question, I think it's worth going back around a decade. Coming out fresh out of university, I was a power engineer. So I was focusing mostly on electrical engineering and the power system. So my worldview was centered around the electricity sector and the challenges that arise from the electricity sector. And coming straight out of university, I jumped into a project that focuses on heating and cooling. And it was a Horizon-funded project called Cool Heating. And then through that project, I got in touch with the huge challenge that Europe faces with the decarbonization of the heating sector. Because when we're talking about decarbonizing energy systems, the first thing that comes to mind is the electricity system, because we know about wind farms and solar panels and so on. But back then, we had around more than 70%, 75% of the heating demand was met by fossil fuels, which is most the share of fossil fuels in the electricity sector. And the amount of energy that is required for heating and cooling is far beyond that of simply electricity demand in some sectors. So that made it clear to me that heating and cooling are really central to the decarbonizing energy systems in the long run. So then you think about what are the tools that allow you to do that. And if you focus on electricity separately from heating and separately from cooling, you have different islands that don't communicate with one another. And you think about isolated strategies, and it's like running a household budget, but you have the household budget with one pocket only for groceries and another pocket only for etc. And you're not looking at the whole picture holistically. So that led me to integrated energy planning, and I've had the opportunity to work with some wonderful people from the academia, from governmental organizations and international institutions. And 10 years later, here I am working at the university as an assistant professor and doing my research still mostly on this topic and tackling it from different angles.
That's really interesting, and thank you so much for this very comprehensive view of what you've been doing so far and how it's unfolding. Louise, your work also is very multidisciplinary, right? You've been working at the crossroad of buildings, housing, and energy systems. What made multi-apartment buildings and limited profit housing such a entry point for you in the energy transition? So for me, it didn't start a decade ago, but it also started in university. So I wrote my master's thesis on the limited profit sector in Vienna, which I feel is just a very cool construct basically to look at, because it's quite a unique model that the Viennese social housing sector has, where you can really see that this does have a buffering effect on rent levels and also involve, let's say, more of a mix of different people with different backgrounds. So there's no social stigmatizing going on. And my focus on this work was basically looking at the ecologicalization of the limited profit housing sector. And through interviewing some of the social housing organizations in Vienna, I saw that some of them really do some pioneering work in terms of like upgrading the energy efficiency of the buildings, decarbonizing the heating system. And the thing is that they all operate under the limit profit principle. So all the money, let's say, they generate goes back into the sector, goes back into the building. Through that, like bigger housing organizations, they can also use their funds upgrading the building shell, changing the heating system. And I thought it was just great to see this development, because through this, one can combine the aspect of affordability with also clean heating. And this is where we need to go, right? So to leave no one behind in the heating transition. So that was my entry point into basically looking more into how buildings can become climate ready, also affordable, still keeping rents and systems affordable. And then I started diving deeper into, let's say, just the heat pump trajectory through my work here at the Austrian Energy Agency, where we coordinate life-funded project called InstaRes, which we use to look at different technical solutions, but also business models that can make the heat pump rollout simple and affordable. And we focus on existing buildings here. And as my background, as you said, it's more interdisciplinary, it's more on the social science side. I'm also looking more at the social factors. So not only how heat pumps can enter buildings in a technical sense, but also in the social sense. So how we can ensure that people can afford heating and the transition, and also accept this, let's say, for some still very new technology. That's really super interesting, because the Vienna, let's say, social or public housing system is like a blueprint for Europe's affordable housing. And you've been looking at it with the different approach, different lenses. And really, it's like about system integration. But what you do, Vladimir, is also about system integration, but with a more technical approach. So why does it matter to make those concepts work, integrate really in practice? Because as I said in the introduction, we have a kind of challenge with the fact that we forget to work with one another. The InstaRes project is really, and the work you've been doing so far is about bridging those gaps, right? So why does it matter so much? Let's start maybe with the social science perspective with Louise. Yes, I think it matters a lot, because as I said, so we need to combine the technical side with the social side to make it also affordable for people to know how to use it. And the coupling, let's say, from before there was heating on its own, electricity on its own, mobility on its own. And now through the electrification, basically all these different systems, they use electricity to run. And this can bring a lot of, let's say, there are a lot of synergies that can evolve through this way. Also, let's say, with the possibility of making life easier for people. So that through, let's say, coupling these different sectors, we can also manage them easier, or let the technology manage them for us, so that we, in the end, as the tenant or the one living in the building, don't need to think that much about, okay, when do I charge my EV? When do how does my heat pump work? But rather getting the best out of the energy that we have. So maybe if we have a PV system on our roof, then it's great, because we produce our own electricity, and then we can be sure that this electricity is used to, let's say, fuel our heating, our heat pump, or our electric vehicle. So Yeah, I would say the social side of this, or what matters to tenants as well, is that it's the possibility of having a free mind, let's say, and being sure that the system works in itself if there's system integration. Yeah. Is it something that, let's say, the engineers are also looking at? And how, Vladimir?
So from the engineering perspective and from the technical perspective, what users in energy systems are designed to do. So what energy systems are designed to do is they're designed to provide reliable, secure, and affordable energy. So comparing energy to other goods and services, consumers usually derive a certain preference and individual value from different goods that they're buying and consuming. I don't think that energy falls within that category specifically. But what we want is we want our electricity on, we want our homes heated or cooled, and we want to be able to move around. So it is the end uses that we should be meeting. Meeting those end uses, we should be able to find the technologies and the business models to fill those gaps. So the end uses are essentially the goal that we're pursuing. We want to meet those end uses, that end energy demand. So how we do it is we have multiple options. Let's say, as we want to decarbonize our energy systems, we know that we're introducing more variable and intermittent renewable energy sources. And if we're looking only at one sector, we will be searching for the options and the solutions only in that sector. So let's say if there's more wind or more solar energy generation, and we're looking only at the electricity sector, then we would be thinking about installing more batteries. But why not installing more thermal energy storage, which is sometimes orders of magnitude cheaper? And if we can install thermal energy storage or use the energy storage in the sense of thermal isolation of our buildings, because when we slightly overheat our buildings, they act as certain buffers. We can think of these integrated approaches in a way that finally the needs of consumers are met. And in doing so, we also have to think about how we deploy these technologies, because some of the technologies may have some upfront costs that are challenging for the wide public to adopt or to pay. So we have to think about not only the technical implementation, but also the business model and the economic implementation of these new technologies in our way towards more affordable, towards more decarbonized and sustainable energy systems.
And that's exactly what the Install Rest, the live project, Louise, you mentioned, is about, right? It's about the combination of business models, coordination, and really not only communication, but adoption really shape how heating actually works in multi-apartment buildings. But there is something you mentioned, Vladimir, it was about cooling. You come from Northern Macedonia, so you have huge experience in very warm summers. And still, we talked about that earlier, but cooling is kind of forgotten and it's still treated as secondary in many discussions. Why is it a mistake, especially in multi-apartment buildings? And why are heat pump a good conversation starter when we talk about cooling?
Yeah, well, heat pumps maybe have gotten their name slightly unfortunately because they only show the heat aspect, or they only indicate that there is a heat aspect. But heat pumps are essentially reversible refrigerators. They can either heat our home or cool our home, and they can do both things. And I wouldn't say that it's a forgotten question, but I think that it's a question that the public, policymakers, engineers, and essentially system planners are waking up more and more. As our climate changes, we are seeing abrupt heat waves. We're seeing temperatures that make it very difficult for people to go to work, to function, to go outside, to go about their everyday lives. And coming from North Macedonia, we've had summers that have had extremely high temperatures for a while now. Cooling has not been a question that we're waking up recently. It's been a question that we've grappled with for over the past decades. So maybe some of the experience can be directed and shared with other countries. But as our climate changes, I think that in the future, we will see the growing need for cooling energy. And this is an aspect that we have to take into consideration. So traditionally, we've been thinking about heating and cooling separately. But what we should be thinking about we should be seeing them as different sides of the same coin because we can solve them or meet them with the same technology, and that's heat pumps. So the idea is, if we're thinking about introducing a gas boiler or a wood boiler or some other technology for heating, and we need to cool our home, then it's introducing two different technologies to supply the different sides of the same coin. But with heat pumps, we can do them with the same technology. And for multi-apartment buildings especially, that's very important because we are not thinking about the infrastructure costs of one apartment. You're thinking about the infrastructure costs for the whole building. And that's not only a technical, the engineering perspective in the sense of electricity, heating, and cooling, but that's also an architectural question. How are we going to go about designing the buildings? What impact will it have on the outside look of buildings? And how will our cities change if we need to find individual solutions to cooling, or maybe a centralized solution to cooling? So I think that heat pumps shine when this question comes to mind, and they solve this question simultaneously, both heating and cooling.
That's really interesting. And what you said about the policymakers starting to take the cooling need into consideration is indeed like growing. Last year, I saw the report for the European Commission really on summer energy poverty. And, whenever I presented it to policymakers, some of them were saying, oh, it's an eye-opener. I didn't realize that heat waves and the heat in general is killing more people yearly than the cold is. But in Europe, we're talking about 60,000 deaths every year over mortality because of the heat. So it's no longer becoming a luxury to have access to a cooling system. It's becoming like indispensable for human life, especially if you are older, if you are pregnant, if you have small children at home. So that is becoming like part of the mainstream equipment in a home, like a washing machine. But at the same time, the infrastructure that is needed to make it happen is a little bit more maybe visible, or maybe a little bit bigger, also because heat pumps are using a lot of electricity. They're using a lot of energy in general. So there is also conversations to have about the resilience of the grid, about like the affordability, making sure that more people can also access this kind of technologies. Louise, I would like to bring this to you, since you mostly work on multi-apartment buildings, and one of the, let's say, big challenge related to the cooling system is that it contributes to the urban heat island effect. So basically one device can, since it blows hot air in the atmosphere, it overall, instead of cool the neighborhood as well. So is it a conversation? Like, how is the need for cooling being approached in Austria, especially in multi-apartment building? Is it becoming something like mainstream as well?
Definitely. I think also in Austria, especially living in Vienna, a city where in the neighborhood that I live, there's a lot of concrete, little trees and everything. It's something that definitely enters also the everyday conversation with friends, with colleagues, thinking about, yes, I'm looking forward now in winter, I'm looking forward to the summer, but then, oh no, but then it will get that hot again. So it's something that since people just experience it directly and often also have little possibilities to forgo this, because especially with the building structure in Vienna, with, for example, I live in one of these, let's say, like old apartment buildings under the roof. So there's little we can do to cool. Of course, we do everything we can do with opening the windows in the evening. But if it's 20 degrees plus outside, then even then it doesn't really cool down that much anymore. So I feel like that is, as Vladimir said, it's something that it's entering the conversation, but it's something that we need to stress more and more and show that this is just, and it will become a way more important benefit in the future for people if they also have a system that I can at the same time also cool their building. And I can give an example from one of the demo sites that we have in Austria, where they are basically implemented a heat pump through facade integration. So They don't talk about active cooling because it's more of like a tempering of the facade, let's say, in summer. So it's normally 2 degrees cooler than outside through the system, which might not sound that much. But there was one instance when there were some technical problems with the whole system, and it's like it stopped working for 1 or 2 days. And instantly people were calling, it's so hot in my room, what did happen, and everything. So they could see that even though one thinks, okay, it's not a big difference, it really does make a difference, and it affects their living comfort in summer dramatically.
Maybe it was affecting like humidity or something, and that was leading to a greater feeling of discomfort or something like that.
Well, exactly. Even these 2 degrees, they made a difference in their comfort.
Yeah. One of the big challenges, or maybe the biggest challenges, is the upfront costs for equipping buildings with this kind of comprehensive solutions. Again, here we are not talking about detached house trying to get equipped with some heat pump, but really we're talking about collective heat pump or collective system to heat and cool, right? Yet the upfront costs, they remain one of the biggest barriers. Why is it still so expensive to install such systems in collective buildings? And who's carrying this cost?
So I would say in Austria, of course, it's a complex things that play into these high upfront costs. So, I mean, you'd pay the heat pump itself, the installation, possibly you need to drill into the ground, possibly you will need to finance renovation measures. I think in Austria, like the installation is a big part of these upfront costs, but I know from other colleagues in Poland, I think it isn't that huge of a role. So I think it really depends also on the context one is in. But of course, it's still one big thing. Like people maybe don't know yet that well what to expect. So I think there's quite some, not say skepticism, but rather little experience, which also deters people from going because it's something new and they're not sure, does my building need to be upgraded in some way or the other? What will it cost me throughout the lifetime and so on? So I think this is also why some people might refrain or rather slow to adopt. And this is something that we also, as part of the project Inside Rest, we want to work on. So giving people more tools to easily decide or understand what will it cost, what will I need to do, and so on, to make it easier for them or more predictable for them to know how to do the investment.
Yeah. Also because there are so many differences, like the installation it can go from 5 to 20,000 just for one individual apartment or house or something. So the difference is absolutely huge. So you need to know if you are making the right choice. Like it's such a big investment. It's just a lot of money. It means that like probably most of the people cannot like make the purchase immediately. So how do you see that happen in the context you are experiencing and what you are observing as well?
Yeah, so this is a very, very important and very difficult question that you're addressing, and maybe it's at the heart of the challenges of heat pump deployment. It ties to everything from misinformation to poor deployment and poor experiences in the past that may hinder the future experiences. The lack of experience of some installers that take on the deployment and installation of heat pumps that may lead, because of the steep learning curve, that may lead to higher installation costs. But it's also a question of the power purchasing parity of the households that are essentially buying, because across Europe, we see households with highly different standards of living and average salaries and the costs. And we may adjust those investment costs based on the purchasing power of households, but it's still a huge difference. And I think that one of the underlying problems here comes from the fact that people don't think within 10-year intervals. And it's very difficult to have a spreadsheet of economic calculation in your mind, because when you're looking at of quotas from different installers of heat pumps, and you're finding that the cost for the installment would be around 6, 7, 8,000 euros maybe, and you're comparing that to, I don't know, a pellet boiler, a wood boiler, and I'm thinking about pellets and wood because we don't have a secondary natural gas distribution system, and the natural gas is not used in North Macedonia for heating in almost all cities, with the exception of a few, and you compare it to the cost of a wood boiler, it's hugely different, and that deters people. So the high upfront cost deters people, and that's one of the main challenges. But then we have to take into account then what happens with the life cycle and the usage. And I will go back to a point that you made, Marine, earlier, and you said, but heat pumps consume a lot of energy. And yes, that's true, but that's subconsciously one of the myths that we take on every day. And yes, they consume a lot of energy, but we also have to say that they consume 3 to 5 times less energy than the alternative. And when we put it into that perspective, then it's not a lot of energy. Essentially, what we're saying is they will save a lot of energy compared to wood, natural gas, oil, or whatever other alternative. They actually save a lot of energy. Yes, they will consume a lot of electricity, of course, but they will save a lot of fossil fuel usage. So I think that we have to find ways of communicating the additional benefits of heat pumps beyond the upfront investment cost. We have to talk about the cost on a monthly basis. We have to talk about the savings. We have to talk about the comfort. The European Union and North Macedonia, although a country that is not part of the European Union, but the Western Balkan region as well, we're having an aging population. And I'm talking right now about the Western Balkans, where we have traditionally been using a lot of wood for heating. And we see a lot of these aging households with older people living alone, and they have to take care of chopping wood and preparing the stove and preparing the boiler and doing all the manual and physical work. And it's a question of comfort. It's a question of different type of energy poverty beyond economic. So these are challenges that we're almost single-handedly solving by this new technology. And yes, there are challenges to deploy it, but this, as Louise said, this InstallRes project is intended to do that. So it's a huge challenge to take on, but worth taking on.
No, that's really great that you bring the example of North Macedonia and people collecting wood for heating or even for cooking. Some would argue that collecting wood is free. So, whenever you add the cost of a new technology, that adds the cost. So that adds a lot of new challenges. Maybe it's not affordable and so on. Well, but you're absolutely right about the quality of life and the comfort, not having to carry huge pieces of wood or pellets or everything. And there is also this summer aspect that is absolutely fundamental, right? So how do you manage to kind of address these concerns? Because I totally get it. Like when someone says, I'm 70, 75, why should I make an investment for something that will show up over the years and maybe in 10 or 20 years when I can have access to something very cheap now? Maybe not energy efficient at all, but very cheap now when they are aging as well. Maybe that's a question for Louise, given that it's more a social science aspect, but Vladimir, you must also have something to share. So Louise.
Yes, I think Vladimir can go more in the North Macedonian example into that. I think one thing or one, let's say, bigger, not say problem, but one phenomena that we discuss here is that, of course, it's a process of installing the heat pump, and it starts with when to install it. And here, I think there are some, let's say, windows of opportunities how to get into the game. So, of course, when the existing system breaks down, or maybe when some renovation works become necessary, that's, let's say, the window of opportunity that opens up for, let's say, people to think about, maybe I could install a heat pump. And I think here it's important to be there at the right moment. So to have the resources, the support for housing owners that think about maybe installing a heat pump to have them there, to take them by the hand, to explain to them, like the things we discussed, what will it cost? What are the things that might need to be done with your building? How will it work? What are the operation costs of it, and so on. So there has to be enough support there, enough materials there to support the housing owners here. And we have another example from our demo sites from the Netherlands here, which have developed, they call it the heat comparator platform, which is a very easygoing, low entry website for households to basically let's check out what heat pump would fit to my house, what heat pump would fit to my needs, and enter this information, like little information about the house that is not expert level, but easy for everyone to know. Enter this into a website, and then they get different heat pumps that would fit to their needs, so they can already inform themselves before, let's say. And on top of that, talking about coordination, this platform also gives the possibility to find an installer near you who could install that heat pump. So there we have the whole coordination process, the whole thinking about, okay, what could I do? How could I do it? What do I need to make it easily accessible, or to even the whole process easily for housing owners and have the right tools there.
Vladimir, how have you, so when I describe the situation in North Macedonia with people using a lot of wood for heating, so how are you addressing the situation there, when at the same time one of your objectives is to make sure that Macedonia, since it doesn't have a big gas infrastructure, leapfrogs from wood basically, or solid fuels to heat pumps? So what is and how is the strategy looking like?
Yeah, thank you. That's a very interesting and very valuable point. So all comes down to costs at this point. We're talking about wood, but we're also talking about wood that has an inherent cost. So households have to purchase the heating wood. And right now, when we're talking to households that are changing their existing wood heating systems with heat pumps, they tell us two things. It comes down to costs and it comes down to comfort. Because we have slightly oversized houses that are non-uniformly heated when you're thinking about using a single heating stove or a heating boiler, and you don't have a central radiator system that uniformly heats the house, then you have some rooms that are overheated, others that are underheated, and you have that comfort challenge. And then you have the comfort challenge of dealing with the fuel wood. And on top of that, you have the essentially very high wood cost. So over the past years, the cost of heating wood has grown significantly, and it's becoming a burden. And when households changed from logwood to heating pellets, and they started dealing with supply chain constraints, and there was a time where it was very difficult as Europe was getting rid of Russian natural gas. Then the market for pellets expanded, and then it contracted nationally. So although we had producers of heating pellets, people couldn't get their hands on heating pellets.
Wow.
It was a challenge. It was a challenge from that perspective. And it became, of course, supply and demand overlap somewhere, and you have in the equilibrium, you have essentially a higher price. So this is where, as Louise mentioned, you have to step in at the right time with the right solution. Right now in North Macedonia, that solution are incentives, form of grants that cover a certain percentage of the investment of the heat pumps that range between 20 to 30%, depending on the type of grant that is given. And some are local grants, some are national grants, and some are grants given by international funding bodies. But what this has done over the past years, coupled with the lack of natural gas infrastructure, it has shown that we can think about a system without expanding the use of natural gas. And we can think about supplying the energy demand without essentially expanding, or even in the long term, reducing the share of fossil fuels in that sector. So in the heating sector, we're on a trajectory of using less fossil fuels in heating in North Macedonia. And while the primary natural gas infrastructure is expanding, as time goes by and we see the fluctuations of natural gas prices and the import dependency that it creates, in my opinion, it doesn't make any sense to invest in natural gas infrastructure for heating individual homes, because then we would have the challenges that are on the other side faced by European companies right now. So heating companies, installers, designers, and so on, that have had significant experience with natural gas are now tackling to move from natural gas to heat pumps. On the contrary, in North Macedonia, there were a lot of companies given the lack of natural gas infrastructure, could either focus on wood, pellets, or heat pumps. So that has given time for the industry to mature to a certain extent. And now we're at a point where they're maturing to think about how they can expand the deployment of heat pumps even further, in the sense that, yes, households face these high upfront costs, and we have to think about innovative business models. How do we offer these heat pumps, this technology that we're offering, to make it affordable to even more households? And this is a lesson that we can learn not only about the heating sector in North Macedonia, but there have been multiple studies showing that even countries right now that are facing significant energy poverty, not energy poverty in the sense of energy affordability, but energy poverty in the sense of lack of infrastructure, especially in Africa, let's say. There have been studies showing that you can leapfrog the dependency on natural gas and go straight to using cleaner, sustainable technologies. And this is valid not only for the heating sector, but we also see it in the mobility sector. We have a lot of developing countries that are seeing rising shares of electric vehicles far beyond those of internal combustion vehicles. So it's a lesson that we should be thinking about, and a lesson that we should learn in time.
Yeah, I find it incredibly powerful what you say, because I've seen the same series of articles, I think, and you, about the number of developing countries who are leapfrogging to clean mobility. I mean, it just make more sense. Like, they don't need to import, they don't need to pay taxes. You can recharge at home their infrastructure. So let's apply it really to indoor heating and cooling needs, because the heat pumps have a funny name for something that you can actually use for cooling, and that is becoming absolutely indispensable for living our lives in Europe. But now we are reaching the end of this episode. So I would like you to go with one challenge or one assumption that you would like policymakers, whether at the local level, national level, or European level, or housing providers, something you would like them to question, or some assumption you'd like them to overcome. Louise, would you like to start? Something like, a myth that needs to be undone.
Yes, I think funnily enough, within the project, that's something that Vladimir developed, is heat pump fact check. So we actually have listed some myths that are out there about heat pumps. So yeah, I'll pick out one here. And I think one big misconception for, let's keep it more on, let's say, like individual housing owner level, mustn't only be single family homes, but also multi-apartment buildings, is that heat pumps do not work in existing buildings because maybe the efficiency is not good enough, they're not well enough insulated. And this might have been the case in the past when heat pumps were still, let's say, more in the whole developing phase. But now there have been a lot of technical advancements made. So it is possible to install a heat pump, also maybe not in the most efficient building with highest insulation, also in multi-apartment buildings. Of course, there's always a balance you need to find between what should I insulate in order to increase the efficiency of the heat pump and what works well how it is, let's say. So there mustn't always be changes in the radiators and so on. Often they're sized well enough already. So I feel like that's this misconception that so much has to be done before installing a heat pump, which of course always depends on the individual house. Still, some houses need a lot to be done. But this also, let's say, has the fear of, there are so many other costs that will be there before I can install a heat pump. So I think that's one thing that should be debunked.
Yeah, totally. Yeah, something I heard recently was your house, you will never access comfort over 17 degrees because of the quality of your house or something. I think when my friends shared that with me, I was like, maybe you should consult somebody else, because it seems like one of these big misconceptions coming from a potential installers. But anyway, Vladimir, what would be your misconception you'd like to debunk?
So before debunking any misconceptions, I would like to thank Louise for making that point, because it's a very important and valid point. And we're seeing countless of examples where houses changed their source of heating and they're using their old existing radiators and they feel comfortable during these cold winters that we have in North Macedonia as well. But I would like to take a step back, and coming after a decade from the Paris Agreement in 2015, we're right now at a very strong tipping point where international scene and international relations are risking the global society and community to maybe negatively impact our previous ambitions for climate change mitigation. And one of the arguments where this is most seen is that climate change mitigation or reducing greenhouse gas emissions comes at a cost. So I think that this is a myth that we have to debunk, that although there are costs, we have to be thinking about not only heat pumps, but any of the technologies that we're deploying for a more sustainable future. So we have to think about the whole system cost or the whole societal cost. This is essentially very much pronounced in North Macedonia, where the use of fossil fuels or even old inefficient heating systems of would contribute significantly to air pollution, to local air pollution. And this incurs additional costs to health systems, to other aspects of the economic system, reduced productivity, economic productivity. And these are just one aspect of the multiple costs that are associated with the use of inefficient fossil fuels, old energy elements or energy systems. And by introducing sustainable and cleaner sources of energy and more sustainable energy solutions, yes, we will have to introduce some costs, but then the societal co-benefits hugely outweigh these costs. And these are co-benefits in the sense of health, well-being, impact on society, impact on economic productivity, and so on. So I think this should be the take-home message for policymakers in the future to come.
I love that. If I can add one thing, I think we also need to have another conversation about the taxation of the different energy sources so that there is a better cost parity and we understand better that heat pumps are actually cheaper to run than subsidized natural gas, etc. I wrote a paper on that from the Eichrechtwohl Stiftung, really on affordable heat pumps. So all of this is part of a conversation. But in any case, Louise and Vladimir, I really appreciate your time. I really appreciate what you said. It doesn't have to be about one single home. It has to be about the buildings, the neighborhood, etc. And that's also where we can learn and we can really make sure that there is some kind of a ripple effect from all coming together with a solution that has proven to be totally worth it. So thank you so much, Louise and Vladimir, and see you next time.